Okay, congratulations to those three people who actually did their homework. For the rest of you, here are your answers to the questions you should have done for homework. What is a term? Well, actually what we're talking about is what is an algebraic term, and we talked about it being an expression or a mathematical expression, made up of the product. Now that's really important. The important word is product, which means multiplication. The product of variables or numbers. That's it. A mathematical expression made up of the product of variables or numbers. And of course, I will probably ask you on a test to give an example. So the most simplest one is 2x. That's an algebraic term. It's actually made up of the product of the number 2 and the variable x. The number 2 also being called a coefficient in mathematical circles. Another one, if I said another one, you could say negative 3xy squared if you wanted to, which is made up of the product of the number negative 3 times x times y. And we say y times y because it's y squared. So there's two y's that are actually being multiplied together. But that's just the product of four different things, a negative 3 and x and two y's, right? And we could also say the number 11 is just a number. That's a term. And we could also say the number or the variable z. Just the variable z by itself is also a term. So those four are four examples of different terms you could have in algebra. If it's just a number with no variable, there's two special things we talked about. We said its name is a constant. We talked about that. And we also said it has a degree of 0, because when we talk about degrees, terms that do not have variables do not have degree as well. Second question said, what's a like term? A like term is a term that shares the same variables. I'll put variable or variables. Variable, and then I'll put in brackets s because it can be more than one variable. And corresponding exponents. And we could just say exponents, but sometimes if I said to you, if I just say and exponents, then sometimes if I said xy squared and x squared y, you might think of those two terms as being like terms because they share the same variables x, y, and they both share the same exponents 1 and 2, but they're not like terms. These would not be because this 2 is on the x and this 2 is on the y. So that would be an example of not like terms. But if we are going to do like terms with that idea, we could say xy squared and 3xy squared are both like terms because they share the xy squared, and they do not have to share. What part do they not have to share? What's that word, Madison? What's the word they don't have to share in like terms? The coefficients. This has a coefficient of 1, this has a coefficient of 3. And actually, that segues very well into our next question, which says, how do you gather like terms? You keep the term. You keep the term itself. Keep the term, not the coefficient, but the term, and combine the coefficients. So in the second example, xy squared and 3xy, if I kept the term xy squared and combined the coefficients, I would be able to gather those two like terms to end up with 4xy squared. I know my y looks like an x. Yes. And combine the coefficients. Okay. Question number 4 says, what is this? So the first thing you would say, you can tell me a few things. You could say it's a polynomial, or more specifically, since there's 3 terms, it's a trinomial. And the second thing says, what is its degree? Since this has a degree of 2, 1, and 0, you might be asking, how do you get degree? You look at the variable in the term and just add together the exponents within that term. So there's only one variable, it's a 2 on the exponent. It's an divisible 1, it's a 0. So the degree of the entire trinomial is not 3, like many people think. It is simply 2, which is the highest degree term. Bryn, the next picture has 3 beautiful large squares that are not shaded in, a rectangle shaded in, and 3 small squares not shaded in. What is this expression? Good. Good. A lot of people might have said plus 1x, right? Which is fine, but just don't write the 1 as a coefficient. That is the expression. It's a trinomial. It has 3 different terms that cannot be combined because they are not like terms. Question 6 says x squared minus y plus 3. What is the coefficient on x and y? The coefficient of x is right here. The coefficient of x is 1. The coefficient of y, Carter, is what? No, it's not. Try again. No, it's not. That's better. It is negative 1. So technically, the subtraction sign of minus does actually lend itself to the actual term itself. Even though that is just a y, if I was to draw it, I would draw it like a negative y, right? It would not be shaded in. Because subtracting a y and a negative y are the same value, mathematically speaking. Next question says, write and gather like terms. So the first one here is negative 2x plus 2. The second one is going to be a positive x squared, a positive 3x, and a minus 3. So when I look at these two, and technically, if we're going to go to the next section, I could technically put brackets around it like this and say those are the two polynomials. Now you're going to gather like terms. In a situation like this, Abby, what do we gather first? The terms at y, because it has the highest degree. So we gather the highest degree terms first, since this has a degree of 1, a degree of 0, a degree of 2, a degree of 1, degree of 0. I'm going to gather my x squareds first. There are no other x squared. So x squared is simply going to stay x squared. Done. Next terms that have degrees of 1, I have x's and x's. I can gather those two. A negative 2x and a positive 3x. If I keep my x and gather the coefficients, I end up with a positive 1x, which we know we do not need to write a 1. We could just keep it as plus x. And finally, my constants, a positive 2 and a negative 3 make a negative 1. And therefore, when I gather like terms, I end up with that. And that is my solution. It's a trinomial. Can't be simplified past that. Our last question says gather like terms. We have 1, 2, 3, 4, 5 terms. Interesting. I didn't write any constants. There are no constants, just terms. Degree of 2, degree of 1, degree of 2, degree of 1, degree of 2. Look at my degrees of 2. They're all like terms, every one of them. I get a 2x squared and a 4x squared, which makes positive 6x squared. Positive 6x squared and a negative 6x squared equals nothing. So technically, I could technically write 0x squared, technically. But we know no matter what x is, if I multiply anything by 0, it's nothing. So technically, that term becomes an algebraic zero pair. My x squareds are all gone. Then I have two more terms left. They're both x, which are like terms. A negative 3x and a positive 5x makes the final answer of just a positive 2x. Excellent. And the last question, in honor of JoJo. JoJo charges $15 an hour for tutoring plus a $10 printing fee for materials. What expression represents his cost? First thing you need to do, you need to define your variable x equals number of hours. You would also use h, which is probably more appropriate. I just tend to be a person who loves the variable x because it's classic. So therefore, $15 an hour means that JoJo will always charge $15 multiplied by the number of hours he works, represented by the term 15x. Plus, no matter how many hours he works, he's going to say, listen, I got to give you $10 for the printing fee for the materials I bring to tutoring. So the expression that will be that is this. And if JoJo works for 2.5 hours, how much does he get paid? It's not there, but if I said that, you would substitute 2.5 hours for his number of hours worked. You would multiply that out to give 37.5. Means JoJo's bill for a 2.5 hour tutoring session. No, JoJo charges it. His bill would be $47.50. That's what you're going to pay JoJo for tutoring you. You say his bill, it sounds like his bill. No, it's his bill. He's giving it to you. His bill.